Let's take a look at 2.1, the basic definitions and terminology we need for the second part of our unit here. So we'll be talking about polynomials. Poly meaning many, nomials meaning terms. So they're many terms. And that's what we're going to see. Now, in general, we can get more specific if there's one term, two terms, three terms, and then from there, they're polynomials. So a monomial is a real number, a variable, or the product of a real number and one or more variables with whole number exponents. It means it's one term. There's no plus sign in between. There's no minus sign in between. It's one that's just all thrown together. We could have 10a cubed b c to the fourth d e f g. That's still just one term, and there's no plus sign in between. Now, the degree of a monomial is the sum of the exponents of the variables. So in our example here, we had 3 a's, 1 b, 4 c's, 1 d, 1 e, 1 f, 1 g. So that would be a grand total of 12. So this would be 12th degree. Even though there's only one term, it's a monomial, it's also the degree. And here we have two more examples. The variable has an exponent of 2, so the degree is 2. There's no other variables there. Whereas in the second one, we have two variables, both have an exponent, because all variables have an exponent, 1 if nothing's written. We got 5x is 2y, so total, we add those up, we get 7 variables altogether, so the degree is 7. No, the coefficient doesn't affect the degree. We don't care what number's in front, 15, 1/2, 10, it doesn't matter at all. So, two more quick examples. What is the degree of 8x to the 9th? Well, degree is 9 because there are 9 x's. There's no other variables there, no other exponents, so that's it. The degree of 7xy squared, well, we have 1x, 2 y's, for a total of degree of 3. In this case, we had to add up the exponents because there were two different variables. So we'll give the degree of each monomial. Number 1, there's only one variable, it's x, and there's 7 of them, so it's a 7th degree. The second one here, 5x, there's only one variable, and the exponent's 1, so it's a 1st degree monomial. Again, monomial means one term, mono means one. I didn't stress that enough a second ago. Now 4x cubed y to the 7th, we have two variables, so we have to add up both the exponents. So 3 plus 7 is 10. This is a 10th degree monomial. And then number 4 here, 3xy, the exponent on x and y are both 1. So total we have two variables, so this is a 2nd degree monomial. Moving along, a constant is a regular number. It's an integer. Well, I guess it doesn't have to be an integer, but it means there's no variable. So what do you think the degree of a constant is? Well, the degree measures really how many variables are in a term, and if it's a constant, there are no variables. As we can see here, 7 is the same as 7 times x to the 0, because x to the 0 is 1, 1 times 7 is 7, so it's still the same. So the degree is 0 because we have 0 exponents, or we have 0 variables. So the degree of a constant is always, 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 always 0. Now here we get talking about polynomial again. A polynomial is a monomial, so one term, or the sum or difference of two or more monomials called terms. So we'll have plus or minus in between terms, and that's how we can tell the different terms apart. Polynomials are named according to their degree as well. The degree of a polynomial is the greatest degree of any term of the polynomial or of any monomial in the polynomial. So to get the degree of a polynomial, you need to find the degree of each term, and the largest number is your degree. So if we look at 3x to the fifth plus 9x cubed minus 4x plus 10, 3x to the fifth degree is 5, 9x cubed is 3, 4x is 1, and 10 has no variable, so the degree has to be 0. What's the largest number? 5. So since 5 is the largest degree, the degree of that whole polynomial, I think we missed a term here for some reason. Even with that in, we still have a 5th degree polynomial. Same thing with letter B here. 4x cubed, the degree is 3. X squared, y squared, we have to add those up. They're two different variables. We add up the exponents to get 4, and 6y to the fourth. So the largest number is 4. It happens twice, but it still just happens, that is the largest number. So that is our degree. So give the degree of each polynomial. So let's look at each monomial by itself. 0 is a degree, or 1, sorry, has a degree of 0. X squared, 2, 3x to the fourth, 4x to the sixth. So the biggest number is 6. So we have a 6th degree polynomial. Number 6 is a little bit more work because we have a lot more exponents. 2x cubed y to the 7th, that's 10. 5x to the fourth y to the fourth, that's 8. And x to the 5th y to the 1st would be 6. So biggest number is 10, so it's the 10th degree. X plus 6, well, x just has degree 1 because there's just one variable. 6 is a constant, doesn't have any variables, so the degree is 0. Largest is the 1st. Moving along. When they only have one variable, it's pretty easy to see the degree of each term. And then the biggest one, of course, is not the 1/3, because that's not a thing, but the 3rd degree. In number 9, we got 2, 1, and 0 degrees. So it's a 2nd degree polynomial. And then number 10, we have 2, 2, and 2. They're all the same, but they're all the largest number as well. So this is a 2nd degree polynomial. So degree, not too bad. It's really the number of variables, or number of all the variables added up in each term. So one way that polynomials are named are by the degree. So we have our basics here. Again, degree of 0 is a constant. Degree of 1 is linear. That's what you dealt with in Math 1. You solved for one variable, you graphed a line, so degree of 1. What we're going to be looking at this year, really, is quadratic, and that is a degree of 2. Now, quad, we're thinking means 4, but quad in this case means squared. And I know that's kind of confusing. Square has 4 sides, hence the quad part of it. But quadratic means that we have a squared variable. And we do. We have x squared. Cubic is for our 3rd degree. And then after that, it's 4th degree, 5th degree, 6th degree, 7th degree, and so on and so forth. There's no more specific names after that. So find the degree and then name it. 4x minus 6. The degree of 4x is 1. The degree of 6 is 0, so the highest number is 1. So if we have a 1st degree polynomial, it has to be linear. Again, we go up to our chart. 1st degree, linear. Second one, we got a degree of 1, 3, and 9. So it's a 9th degree. And there's no name for it. There's nothing special. So we just call it the 9th degree. We've got a couple more examples here. Should be getting better at figuring out the number of degrees. So it's a 2nd degree, which makes it a quadratic, which again is going to be our focus all first semester. We have 0, 1, 2, and 3 degrees, so it's the third degree. Third is cubic. And then the last one, we got degree of 5, 6, and 7. Largest one is 7th, so it's a 7th degree polynomial. No special name for it. Well, polynomials are also named according to how many terms they have. And we kind of talked about that already with the monomial. Monomial, again, mono means one. If we look at binomial, bi, if we're talking about bicycle, biped, a bicycle has 2 wheels, a biped has 2 feet or legs. I don't remember which it is, but both are true. So bi means 2 terms. Tri, like a tricycle, means 3 terms. And then anything after that is just polynomials in general. Just like we saw linear or constant, linear, quadratic, cubic, and then after that, it's just the number with the th degree. Same type of thing here. After 3 terms, we just call them polynomials. And the terms are separated by the plus or minus. So 4x minus 6, there's 2 terms. We have a 4x and we have a 6 separated by the minus sign. So there's 2 terms, so it's a binomial. Now if we want to talk about degree, that's something different. That has to do with the exponents, not the number of terms. Letter B, we had 3 terms there because we have 2 plus signs separating all 3 of them. So that would be a trinomial. And again, that's going to be our focus this semester. We're going to be looking at specifically quadratic, so squared, quadratic trinomials. So it'll look like this, where A, B, and C are just numbers. It's quadratic because the biggest degree is 2, x squared. Trinomial has 3 terms. That's what we're going to be looking at, something that looks like this. Name each polynomial based on the number of terms it has. In number 14, we have 3 terms, the x squared, 3x, and the 6. So that's got to be cubic. Oops, number of terms, sorry. That's not the right classification. Trinomial, and nomial means terms, so trinomial literally means 3 terms. In 15, we have 4 terms, but after 3, there's no special names. It's just a polynomial. 16, we have 1 term. 1 is given to us by the suffix mono, so this is a monomial, because there's 1 term. So for each polynomial, we can use the degree and the name based on the degree, the number of terms, and the name based on the number of terms. So it's kind of like classifying triangles by their sides, scalene, isosceles, and equilateral, but also doing it based on their angles, acute, obtuse, and a right triangle. Kind of what's going on here. So 6x cubed has a degree of 3, so it's cubic, but there's only 1 term, so it's a monomial. So it's a cubic monomial. In letter B, degrees individually are 2, 2, 2, and 0. So the degree is 2, so it's quadratic. And there are 4 terms, so it's a polynomial. A quadratic polynomial is what we would call this. If we look at 17, 2 terms. 2 terms mean we have a binomial. And if we look at the degree, the biggest degree is 1, so it's linear. It's a, I guess, linear binomial. Probably should be in the other order. 18, we have a degree of 0, 4, and 8. So it is an 8th degree polynomial. We don't have anything quite like that, so just 8th degree. And there are 3 terms, so it's a trinomial. 8th degree trinomial. We look at 19, find each individual degree of each term, of each monomial. Largest number is 6, so it's 6th degree. No special name for anything after 3. 6th degree, and we have 4 terms. So again, there's no special name after 3 terms. So it is a 6th degree polynomial. And lastly, we have 6. That has a degree of 0. So it is constant. I mean, it's always 6. It's going to be 6 all the time because there's no variables. And there's 1 term, so it's a constant monomial. So nothing too crazy. That's it. That's how we name our polynomials. I do want to add in a couple different things here. This is our homework. I figured we'd do a couple problems in class together to get us started. So that has the name of each polynomial. We have standard form. Don't think that we mentioned that here anywhere. I don't know how we missed that. But standard form is where we put the terms in decreasing degree. So the biggest degree first, then second, then third, and so on. And quite honestly, that's what we do anyways. In number 4, of course we'd write our x cubed first, then our x squared, then our x term, our linear term, then our constant. Same thing with number 6. We'll skip 5 for a second. So negative x squared, because that x squared is negative, not the 9. And plus 5x, and that 9 is positive. That's in standard form. Just decreasing order. And if you have to combine like terms, if there are like terms, do that first. So 10, where we add, all we're doing is we're adding like terms. If it helps, you can line it up so that we make sure that we get the right things added with the right things. So just writing one above the other, and then we can just add straight down. Negative 8 and 12 is 4, 3x and 6x is 9x, negative 5x squared, negative 2x squared is negative 7x squared, and 4x cubed and 2x cubed is 6x cubed. It's already in standard form because it's usually how it's written. And we have 4 terms there. We could combine all the terms. So the parentheses didn't really mean much. Now whereas 11, subtraction does mean something different because we're subtracting all those things or we're adding the opposite. So there's a couple different ways we can write this. So the first one, x to the 4th minus 3x cubed plus 5x squared plus x minus 4 doesn't change at all because we're not subtracting that, we're just starting with that. But then we're subtracting those 4 terms. So distribute the negative to those, and then we can just add them up. So there is no x to the 4th term. So minus x cubed is, well, a negative x cubed. Minus a negative 4x squared makes it a positive 4x squared. Minus a negative 11x is a positive 11x. And minus 10, well, it's just minus 10. Now we can just add up our like terms. X to the 4th minus 4x cubed plus 9x squared plus 12x minus 14. We also can just kind of write it underneath it. Oops. So you just flip the signs of all the terms here, which is what we did, and then just add your like terms looking at that. So nothing too crazy. Make sure that we're not missing terms. Lining them up always helps. And remember, if there's no sign in front of it, that really means it's positive. So this 12 is a plus 12. The 6x is a plus 6x, even though I didn't write it. So we got standard form. We can add and subtract. We can talk about degree and we can talk about the number of terms. And that's the basis of 2-1 regular basic polynomials.